So, chapter 3 was all about the graphs. So you take a sample, or you have some data, the first thing that you do is you display it in a graph. And then chapter 4 is all the numeric ways of describing that data. Okay, so there's a few different measures of center. There's the mean. You need to know the formula for mean. You need to be able to substitute for mean. You need to be able to show the answer. You need to be able to show how to do this on the calculator. So starting at the beginning, do we know the formula for mean?
Yes. Yes.
Okay. Do you know how to find mean on the calculator?
Yes.
How?
One variable stats.
One var stats. Okay, and then the symbols, hopefully you remember, are x bar and mu. X bar is for sample, mu is for population. Median is the other measure of center. Okay, first of all, for mean. Mean is not always a part of the data set. So sometimes you guys get a mean of something like 1.6 children. That doesn't make sense, but that's still the mean. Don't round it so that it makes more sense. Just keep it at 1.6. Median. If I have an even sample size, like a sample size 20, which observation is the median?
The middle one. The average of the
10 and 11. The average of 10 and 11. And I want to see that x sub 10 plus x sub 11 over 2. If it's odd, like a sample size 21, which observation is the median? 11. Okay, personally, I don't ever remember that. I just think of a smaller sample size and do it in my head. So like even sample size would be a sample size 4, in which case the median is the average of 2 and 3. You can see that in your head. So therefore, 20 has to be 10 and 11. So if you can't remember it, just pick a smaller sample size. What's the symbol for median?
There is none.
There is no symbol. Okay, mean versus median. Either one could be used as a measure of center. If it's a symmetric distribution or a symmetric sample, use the mean. If it's a skewed sample, use the median. That's because the skew affects the mean but not the median. Trimmed mean. So a trimmed mean is when you ignore the lower certain percentage and the upper certain percentage of a sample. So a 10% trimmed mean ignores the top 10% and the bottom 10%. So basically it gets rid of outliers or unusual observations. You have to remember that a 10% trimmed mean actually trims 20%, the lower 10% and the upper 10%. Okay, between trimmed mean, mean, and median, which of the three is least resistant to outliers?
Median. Wait, no, least resistant.
Least resistant. Mean.
Least resistant?
So
okay,
not resistant.
Yep.
Okay, moderately resistant is the trimmed mean, and then the most resistant to outliers is the median. Okay, mean, median, and trimmed mean are all for numeric data. For categorical data, all we really calculate is proportion. What are the symbols for proportion? P and pi. Okay, here's the part that's confusing. We use P and pi. The AP test and other books use P and P hat. P hat means sample, P means population. Please remember that proportion is always between 0 and 1. So like a p-value, that's a proportion. So when you guys give me a p-value of 1.3, you did something wrong. Measures of spread. So variance and standard deviation. Variance is just the square of standard deviation. So your formulas are these. Remember that sigma is population and S is sample. So population, variance, population, standard deviation. Population or sample, variance, sample, standard deviation. You need to know the formula. So that is the formula for variance. The formula for standard deviation is on your formula sheet. You just have to be able to recognize which one it is. So on the formula sheet, it's S sub x. Make sure you show the substitution. Calculator, same thing, 1 var stats. Calculator only shows you standard deviation though. Okay, this is the one thing to remember. For standard deviation on the calculator, do you use S or sigma?
S.
Is Chris the only one that has an idea of which one to use because the rest of you are just staring at me? S. It's always S. There's only one time when you use sigma on the calculator, and that's the time where it says S equals and then it's blank. Always use S. If you're looking for variance on the calculator, you have to take S and square it. I don't want you to actually type out the S decimal. Do we remember where to find S on the calculator?
Yeah.
Yeah, under bars and then stats. Okay, units for variance are units squared, and the units for standard deviation are just the same as the units of the distribution. They're both always positive. We use standard deviation because it has the same units as the distribution. That's why we don't use variance. Okay, box plots were also randomly in this chapter. Each box plot, you need the 5-number summary, which is the minimum, Q1, Q3, the median, and the maximum. You can find that under 1var stats. They're listed in that order. Outliers, if you have any observations that are less than Q1 minus 1.5 IQR or greater than Q3 plus 1.5 IQR, those are outliers. Your calculator has 2 different box plots. It has one box plot that shows the outliers, and it has one box plot that does not show the outliers. And you can see that from the picture. Do you guys know what I'm talking about? Okay. IQR, that's an acronym. What does it stand for? Interquartile range. What does Q1 stand for? Lower quartile or first quartile. This is something that a lot of you messed up on. Let's say we have this box plot. What do you call that?
15 to 20.
Okay. Do we realize that this is not a quartile? That a quartile is one specific point? So this point right here is the first quartile. A lot of you tend to call this area like the first quartile or the second quartile. That's not the case. These are the observations between the lower 25 to 50%. Please do not call it a quartile. A quartile is a specific point. Okay, so for box plots, you still have to do CSSU. You technically cannot tell shape from a box plot. So if I ask you to interpret a box plot, I want you to give your best guess to the shape, but say in your interpretation, you cannot tell the shape from a box plot. When talking about spread, I want you to compare the whiskers and the lower and upper half of the box, because that will tell you where the spread is widest versus where the spread is narrowest. If you're comparing box plots, you have to do CSSU. You also have to look for overlap. You know what I mean by overlap? Okay. Do those look like the exact same box plot? Yeah, they are, right? Those are the histograms that go along with the 2 box plots. What am I trying to tell you?
You can't tell the shape.
Yeah, 2 very different shapes give you the same box plot. This is one that you guys had to do in the book. It's talking about blood level between whites and African Americans. If you were comparing these, we would talk about center. So this center is higher, so a higher blood level. We would talk about shape. So although you can't tell shape, they both look skewed right, although the white distribution is more symmetric. We would talk about spread. So the African American distribution has a larger spread, some more variability. And then you would talk about overlap. What overlap would we point out in this case? You know what I mean by overlap? Jacob?
The third quartile seems to be very similar.
Okay, yeah, or the same. By third quartile, you mean this point, right? Not those?
Yeah.
Okay, yeah. I would probably say the middle 50% of the African American distribution is contained within the middle 50% of the white distribution. The upper 25% of the white distribution is contained within the upper 25% plus you of the African American distribution.
Thank you.
We get the point. Just a few comparisons. You don't have to talk about every single part of the box. Okay, this is also when we did the empirical rule. The empirical rule is used for approximately normal distributions, not every distribution, just approximately normal. Okay, we'll go back. This is also when we did Chebyshev rule. That's not on the AP test, so you don't need to know it, but you do need to know the empirical rule. If a distribution is approximately normal, then approximately 68% of the observations are within 1 standard deviation of the mean, approximately 95% are within 2, and approximately 99.7 are within 3. If you can't remember that, you should be able to just figure it out using inverse norm on your calculator. We also did z-scores. So the z-score was the statistic minus the parameter all over standard deviation. It tells you the number of standard deviations away from the mean that you are. So one that we did in class was about like test scores, I think. So if I have a standard deviation of 0.1 compared to my class, and Travis has a standard deviation of 0.3 compared to his class, or compared to you all, who did better, relatively? 0.1, 0.3.
Sure. I didn't hear that
Do you
question.
guys know the answer?
What was the
You
question?
just don't want to talk?
I honestly wasn't paying attention.
Okay, do we realize it's 0.3? We just want to make things awkward and stare at me and make me miserable right now? Yeah, we do? Hopefully we do, because your question today is about z-scores. Okay, and then percentiles tells you the proportion or percent of observations at or below that value. So if you're at the 80th percentile, 80% of people scored at or below where you did. There's two definitions for percentile. Thank you. Some people do percentile as strictly below that value. So if you are at the 80th percentile, 80% scored strictly below your score. And then some people interpret it as at or below that value. So 80% of people scored the same that you did or below. It doesn't really matter, it's just a difference of opinion. Okay. So if I have a mean of 64 and a standard deviation of 2, then I would ask you to find the score that you would need to be at the 90th percentile. If we assume that this is a normal distribution, this is what that would look like. So the probability of your z-score being below some value, some percentile is 0.9. This is where in the calculator you do inverse of 0.9, inverse norm of 0.9. Gives you this z-score and then you solve for x. You guys remember doing that?
Yeah.
Yeah, so it's something like the probability of z being less than some z star is 0.9.
Sure.
So then you do inverse norm 0.9, and that gives you the 1.282, and then you use the z-score formula to convert it back to a test score. Do you guys remember what inverse norm does?
Sure. No.
Okay, so you remember how with normal CDF you put in two bounds and it'll tell you the area in between? Right? That's what normal CDF does. What inverse norm does is you input a lower area and it gives you a z-score that corresponds to that lower area. So you tell the calculator something like, if I have a distribution and this point 40% is below it, if you do inverse norm of 0.4, it will give you this z-score.
Wow.
No need to be sarcastic. If I tell you that this upper part is 5%, inverse norm does not do upper, it only does lower. So you would do inverse norm of 95%, and it will give you this z-score. Now, do we remember doing that?
Wait. Wait. Oh, never mind. Good job.
Okay, good talk. Okay, that was chapter 4. Any questions, comments?